Hi. In our last video on complex numbers, we talked about the trigonometric, the exponential, and the polar forms of complex numbers. In this video, we're going to talk about how to perform operations when your complex numbers are in polar form. So we'll start with addition and subtraction. So if we wanted to add together two complex numbers, both of which were in polar form, the bad news is we can't do it directly. So we're going to have to convert each one of the complex numbers to rectangular form. We'll perform the addition or subtraction from that stage, and then we'll convert back to polar. So let's do an example. So I want to add together Z1 and Z2, both expressed in polar form. So in order to convert into rectangular form, I'm going to, you could either say, A equals R cosine theta and find your A, and then B equals R sine theta and find your B, or I'm just going to write it in basically trig form, which will get us to our rectangular form. So Z1 plus Z2. So I'll rewrite Z1 in trig form. So that's going to be 5 times the cosine of 30 degrees plus I times 5 sine 30 degrees. So that's our Z1. And to that, I'm going to add Z2, which is in trig form, 4 cosine negative 60 degrees plus I times 4 sine of negative 60 degrees. Okay, so now it becomes mostly a calculator problem. So you could do some of this manually because the angles are critical angles, but we're going to just plug it into our calculator. So 5 times cosine 30 degrees gives me 4.33. I'm just going to round everything to 2 decimal places, plus, and then 5 times sine 30 degrees is 2.5, so 2.5i. So that's Z1 in rectangular form. Now, we'll add to that Z2. So 4 times the cosine of negative 60 degrees is 2. That one we could have figured out. Plus I times 4 sine of negative 60 degrees. So that's actually going to end up being a negative value. So I'll say 2 minus 3.46i. So that's Z2 in rectangular form. Now all we have to do is add the real parts. So 4.33 plus 2 is 6.33. And then add the imaginary parts. So 2.5i minus 3.46i. So I'll have minus 0.96i. So that's the addition. It's completed, but it's in rectangular form. Since we started with polar form, we're going to go back to polar form. So how do we do that? Well, we find our R, which is just the square root of A squared plus B squared. So 6.33 squared plus negative 0.96 squared, and that ends up being approximately 6.40. Theta is going to be the inverse tangent of B over A. So that's going to be inverse tangent of negative 0.96 over 6.33, and that's approximately equal to negative 8.62 degrees. So let's think a minute. Does that actually make sense for our theta? So I'm going to do a little quick and dirty sketch here. So if Z1 is 5 angle 30, so angle 30 degrees, magnitude of 5, I'm going to say that looks pretty good. And then Z2 is negative 60 degrees for my angle, and 4, so negative 64. Okay, so let's pretend that that's getting us to Z2. So if I think about what the resultant vector is going to be here, I could do that. Basically, all I want to see is if this should be a fourth quadrant angle, because that's what I'm ending up with here. So this is going to be my sum vector, the result of summing these two complex numbers. So remember your physics, this is basically just vector addition. So this is a fourth quadrant angle, and that's what I got here. So we're good to go. So this is good. So that means Z1 plus Z2 in polar equals 6.40 angle negative 8.62 degrees. Okay, so that was addition, and subtraction would be the same thing. You have to convert to rectangular, do your subtraction, and then convert back to polar. All right, so let's talk about multiplication. That's much more convenient in polar than addition and subtraction is. So if I want to find Z1 times Z2, where I've got Z1 and Z2 in polar form, let's think about what's going to happen here. Let's think about what the operation would look like if we used exponential form instead of polar form, because they're basically the same, just slightly different notation. So if I think about it as Z1 times Z2, but I'm going to use exponential form, what have I got? I've got R1 e to the I theta 1 times R2 e to the I theta 2. Okay, so same numbers, just in a different form. All right, so these are all being multiplied together, so I can reorder them however I want. So I'm going to put my R's together. So I've got R1 times R2, and now I'm going to write E. So what happens? I've got common bases here, so what does that mean? I add the exponents. So E to the I theta 1 plus I theta 2. Common bases, you add your exponents. Well, let's make that look a little nicer. So R1, R2, e to the I, and then I'm just factoring out the I, so I times the quantity theta 1 plus theta 2. So notice what we did here. We multiplied the magnitudes, R1 and R2, and we added the angles. So if I go back to polar form, what does it look like? R1, R2, and then the angle is theta 1 plus theta 2. So if you want to multiply complex numbers in polar, what are you going to do? You're going to multiply the magnitudes and add the angles. So Z1 times Z2 would just be R1 times R2, angle theta 1 plus theta 2. So it is actually quite convenient if you're working in polar and you want to multiply. So let's do an example here. So I want to multiply these two complex numbers in polar. So 5 angle 30 degrees times 4 angle negative 45 degrees. So what am I going to do? I'm going to multiply the magnitudes, and I'm going to add the angles, leaving me with 20 times, or not times, 20 angle negative 15 degrees. And that's my result. So pretty straightforward. Well, let's talk about division. It's equally as nice. So I'm not going to write it out in exponential form, but let's think about what's going to happen. Oh, actually I will. Why not? So if I wrote these in exponential form instead of polar, it would look like this. R1 e to the I theta 1 divided by R2 e to the I theta 2. So R1 divided by R2, we can just kind of pull that off. And then what happens here? How can I simplify the e's? So common bases. So what am I going to do? I'm dividing now. So I'm going to subtract the exponents. So what does that leave me with? It means I'm going to be dividing the magnitudes and subtracting the angles. So if you're doing division, you divide the magnitudes and subtract the angles. So let's do an example here. So same two angles, but now we're going to divide. Or same two complex numbers, sorry. But now we're going to divide. So Z1 over Z2 equals 5 angle 30 divided by 4 angle negative 45 degrees. So we've got 5 over 4. We're dividing the magnitudes, and then we're subtracting the angles. So 30 degrees minus negative 45 degrees gives us 1.25. That's 5 over 4 is 1.25. And then the resulting angle is going to be 30 plus 45, or 75 degrees. So pretty straightforward.